this idea of converting repeating decimal into fractions. Remember, you said, how on earth do you get 0.333 repeated to 1/3? How do you take a repeated decimal and turn it back into a fraction? Any idea? Okay, so for that, I have to show you. We know that this is 1/3, right? Agree? We know that because we learned it several times, lots of times, and we memorize it. But do you know why it's 1/3? Okay, well, let's show you how. First of all, let's expand it. We know that 0.3 repeated is going to look like this forever, right? So the first thing you do, the strategy is, when I give you a repeating decimal, assign it to a variable. Just assign it to a variable. Easy. Okay? Next thing you do is, I don't care how you want to do it. I don't really care. But I need you to start shifting your decimal at least one decimal place to the right to get another equation. Okay? And as long, what we're trying to achieve here is that we want to maintain the repeating decimal on the right-hand side. It's already repeated, which is good. But we still need one more set of repeated decimal. So how do we do it? It's actually easy. Look, if I just move one more to the right-hand side, how do we move a decimal to the right-hand side? What do we have to multiply by? By what? By what? If I want to move, for example, if this is 2.5, how do I make it into a 25? 10. Times it by 10. There it is. Okay, so now, if n is this number and I times it by 10, is it true that I just moved a decimal one place to the right? Yes. And it's going to look like that? Yeah. See that? Watch what happens next. All I have to do is do a subtraction problem. Take the biggest minus the smallest. So here's my biggest. Subtract the smallest. Make sure you align it by column as well. Here's the n equals to 0.333333 repeated. If I subtract it, watch what happens. Subtract. What is 10n minus n? 9n. What is 3.3333 minus 0.3333? So every number here is gone, right? Is that true? You end up with just a 3. Now divide by 9 both sides. N is 1/3. See that?
Magical.
Okay, crazy, right? Let me show you another one. Oh man. Here, try a difficult one. Let's say I have this repeated number, 2.23333 repeated. Now that's going to be a challenge. Okay, what digit is repeated?
3.
Just a 3. So remember the goal is, you just want the repeated digit on the right-hand side. So how many decimal places do we have to move to make sure that I only have repeating digits on the right-hand side?
10.
By 10. So that means if this is n, we start with assign it to a variable. We times it by 10 to make it what? 22.33333 repeated, right? Right? But notice that unlike the first problem, if you subtract it right now, we can't not get rid of everything completely. So unless both of them are the same, we cannot subtract yet. So how do we make them the same? We actually multiply by another 10 based on this. So it's like 100, notice, times n, which means you move 2 places to the right. Is that true? Yeah. Which becomes 223.33333. Now, do we have the same here? Yes. Look at this. Check this one out. Do we have the same digits on the right-hand side? Yes. Once we achieve that, then we can start subtracting. We take the biggest minus the smallest. So here it is, minus 10n. This is 22.3333 repeated. Subtract 100n minus 10n is 90n. And of course, 223 minus 22. This is, you know, this is already canceled, right? So 223 minus 22 is 201. 3 minus 2 is 1, right? Clear? We divide by 90 both sides. And then we have n equals to 201 over 90. And we have ourselves repeated decimal. I mean, we have ourselves a fraction to represent that part. Now, let me prove to you that it is actually correct. 201 over 90, right? Let me see if I can just pull this up. 201 over 90. Let me just put up a calculator here. 201.
That's 2-1.
Oh, wow. 201 over 90. What was the decimal before? 2 point what?
2.233.
Okay, watch what happened. There it is. See that? Zoom in. There you go. See that? This is how we do it. So if you want to learn how to do it, it's already included in your lessons for today. And just watch it.